to my YouTube channel. Today we'll talk about QStack. First of all, we discuss what is queue. Queue is a linear data structure that follows the first in first out principle. This means that the first element added to the queue is the first to be removed. And what is stack? Stack is a linear structure that follows the last in first out principle. This means that the last element added to the first one to be removed, similar to a stack plates. This is a queue stack chart. This queue stack chart push friendly stack using a queue for push operation. In this approach, all push operation happen in one queue. It's called push queue. The pop operation reverses the last inserted element by dequeuing and reinserting elements until the last one remains, then it's removed. The simultaneous, the last in first out behavior of the stack. Pop friendly stack using a queue for pop operation. Here elements are pushed normally, but popping is optimized by always keeping the last inserted element at the front of the queue. The top row shows the standard stack with detect, push and pop operations. The middle and bottom rows illustrate how a stack can be simulated using queue with a different optimization. Okay, now let's move on to the queue stack code. This is a queue stack. First of all, we create a Java class file. This is the Java class file. This is a Java class file. This code implements a stack using two first in first out. Since the queue naturally follows FIFO order, extra operations are required to minimize the last in last out behavior of a stack. Here how code works. Data members private queue T, you can see primary queue and secondary queue. These are the data members. Q1 store the actual stack elements. Q2 is a temporary queue using for rearranging elements. And constructor, you can see the constructor Q1 new linked list, Q2 new linked list. This initialize both queues as linked list. Then push operation, you can see the push operation. The new element is first added to the queue 2 which start empty. Then all elements from Q1 are removed to Q2, ensuring the newest element stay at the front. Finally, Q1 and Q2 are swapped so that Q1 always acts as the stack. Then we can see the top element from the stack. This since Q1 row holds the element in a stack order, removing the front element effectively. Pop the last added elements. Another code, pick the top element without removing it. The first in first out method implement then peek at the top element without removing it and check if the stack is empty. Then move on to the main file. This is a Java main class file. This Java code implementation two fundamental data structures queue, FIFO queue and stack queue stack and demonstrate their usage in the main class. Implements a first in first out queue using linked list. T uses Java Qt interface. Methods enqueue D item added an item to the queue. D queue removes and returns the first item in the queue. Peak return the first item without removing it. Return returns to string returns the queue's string representation. Stack implementation using queue implemented the last in first out stack using Java Stack T method. Push T item added an item to the stack. Remove pop removes and return the top item from the stack. Peek returns the top item without removing it. ToString returns the stack string representation. Main class main using main creates a manipulates a queue. In queues 10, 20, 30 prints the queue. Peeks the front of elements. DQ and element are prints the queue. Enqueues 40 and prints the updated queue. Converted the queue into a stack. Queue stack integer, you can see that. Transfer all queue elements into a stack. Prints the stack and peeks at the top elements. Key concept demonstrate. Queue operations තමයි. Queue operations enqueue, dequeue and peek. Stack operations push, pop, peek. Exception handling check the empty queue and stack. Okay, now you can let's see the output. Initial queue 10, 20, 30. Front element 10. Dequeued 10. Queue after the dequeue 20, 30. Dequeue after enqueue 40, 20, 30, 40. Initial stack 20, 30, 40. Top element is 40. This is the output of the queue stack code. I think now you can understand what is queue, what is stack, what is queue stack, how it work, how it code implementation. Now I think you can understand all. Okay, bye. See you next time.